OpenAI gave two AI teams just one single rule: hide or be found. That's it. No strategy guide, no tips, just hide or be found. And they ran 500 million games. And what happened next? The AI figured it out completely on its own. And let's get into it.
Let's look at the numbers first. 500 million games of hide and seek. Out of those 500 million games, 6 completely different strategies appeared. And the number of explicit instructions the researchers gave, 0. The AI invented every single thing you're about to see from scratch. This graph here tells the whole story. Every spike and dip is one team inventing a brand new strategy. 6 times. Nobody planned any of it. Before we get into the chaos, one concept, because it's the whole reason any of this works. When two teams compete, every new trick one side discovers automatically creates a new problem for the other. Hiders get better, seekers are forced to level up. Seekers get better, hiders need to adapt again. Nobody sets the difficulty, nobody writes the lessons. The competition itself is the teacher. That's an autocurriculum. So what does the actual game look like? Physics simulation, a 3D world with words and rooms randomized every single episode. Each team is 1 to 3 agents. The arena has moveable boxes and moveable ramps. Agent can do exactly 3 things: move, grab an object, and lock it in place. 3 actions. That's the entire toolkit. And from those 3 actions, 6 strategies emerged. Here's what makes this crazy. The only thing that gives a reward in this game is visibility. That's it. No reward for touching a box, no reward for using a ramp, no reward for building a fort. Just are you seen or are you not? Hiders +1 every time they stay hidden, -1 if they get spotted. Seekers, exact opposite. That's the entire reward system, and from that one signal, the agent invented tools. Here's the full picture, 6 stages, each one invented in response to the last. Let's walk through every single one. It gets more surprising as we go. Nothing's fancy. Seekers chase, hiders run. For the first 25 million episodes, that is genuinely all that's happening. No tools, no tactics, pure instinct. It looks simple because at this point it is. Million episodes in something changes. The hider discover they can drag boxes together and lock them in place. They start building forts, actual shelters, walls the seekers physically cannot get through. Nobody taught them this. Nobody said build a fort. They just figured it out. The seekers are stuck. They cannot get through the walls, so they adapt. They discover ramps, grab one, drag it next to the fourth wall, climb up, and drop right inside the shelter. The hider's invention just got countered. It took seekers about 75 million more episodes, but they got there. The researchers thought that's probably it. 4 stages seems like a natural stopping point. They were wrong. The hiders responded. During the preparation phase before the round even starts, hiders now drag every single ramps to the far corner of the arena and lock them there, out of reach. The seekers' only tool, neutralized before the game begins. 132 million total episodes to get here. 380 million episodes in, the seekers discover something nobody expected. They jumped onto an unlocked box and ride it, soft it, over the fourth wall. While in the air, this works because the physics engine allows agent to apply movement force while airborne. It's technically a simulator cog. The agent found it on their own. At 380 million episodes, box surfing, completely unprogrammed, completely wild. And the hiders respond one final time. They start locking every single loose box in the arena during prep time. Before building the fort, lock the boxes first, then build. No loose objects for seekers to surf on. Strategy shut down completely. 6 stages, 0 instructions. Here's something that surprised even the researchers. The hiders were never told to work together, no instruction that said cooperate with your teammates. But when there are 3 hiders, they divide the labor on their own. One agent grabs this box, another grabs that one. 3 hiders lock 36% more objects than a single hider would. They share the reward, so cooperation emerged naturally as the most efficient path to winning. When you threw more compute at it, to reach stage 4, a batch size of 32K took nearly 99 hours, bumped that to 128K, 19.8 hours, same strategies, 5 times faster. Scale doesn't change what the agent learned, it just changes how fast they get there. Architecture because it's actually elegant. Every object in the scene, boxes, ramps, other agents, gets in its own embedding, then self-attention runs across all of them. This means it handles any number of objects per episode, no matter what. An LSTM layer holds memory across time steps. 3 output heads handle movement, grabbing and locking separately. Simple architecture, widely complex behavior. That contrast is kind of the point. The agent learned 6 strategies, but did they learn anything actually useful beyond this one game? The researchers took agents trained only on hide and seek and dropped them into 5 brand new tasks they had never seen. Things like lock all these objects or build this structure. The hide and seek agent outperformed the baselines on 3 out of 5 tasks with no additional training. The skills transferred. There's an alternative approach, reward curiosity. Agents get a bonus for reaching states they've never seen before. Sounds reasonable, but look at what happens as the environment scales up. Intrinsic motivation collapses. Agents stop interacting with objects in any meaningful way. Multi-agent competition doesn't have this problem. The pressure to win keeps agents engaged no matter how complex the environment gets. Box surfing wasn't the only unintended discovery. The agent found more. Some seekers learned to ride boxes while completely airborne, without ever touching the ground first. Some hiders figured out they could run outside the arena boundary while using a box as a moving shield. And tiny physics imprecisions in the simulator. They found those too, exploited them repeatedly. They didn't just learn the game, they learned the cracks in the simulation. What this paper is really asking, not can AI play hide and seek? The game was just a container. The real question, can we build environments where intelligent behavior just grows on its own? The answer from this paper, under the right conditions, yes. Hide and seek probably maxes out at 6 stages, but apply the same recipe to a richer environment. Nobody knows what emerges, and that's exactly what makes this exciting. This isn't a finish line, it's a proof of concept.
So, 500 million games, 3 actions, no instructions. The agent didn't learn the game, they learned how to win it. And that's the very different thing.